Hello people! Today we will talk a bit about another module, and because of the things we've spoken about the last 2 times, we actually have enough knowledge to build a working power module that you can charge your phone from. So we'll talk about one module, and I will show you one of my power banks, and I will tell you that you already have all the knowledge you need to build a module like this. Build a power system. Let's see. So, and something to put you against. It's gonna be you. So, I'm gonna start by telling you about this is quite ugly, but maybe we will get lucky. Doesn't seem like we have the one I want to show you. Where is it? There is one. Perfect. So, last time we spoke about a module, this module. We spoke about this last time, and the reason that this is interesting is because it had the, where's my pointing device? Here it is. We spoke about this last time. It had this component on it, some other helping components, but this is the primary component. And this could regulate the power coming from the 5-volt input from the USB cable into a battery cell. So this is a charging module. It's a bad philosophy because it burns off all the excess, but still it's a charging module. And if we take this and say we also want to discharge our battery, because who don't want to discharge a lithium-ion battery? So we buy this other, the cousin of it, or the addition, or whatever you want to call it. You're getting a bit closer, like this. So this is the cousin, and there's a bit more stuff on it. And sorry, I don't know how to do this focus thing. Can you see this? Can you see this? It's not sharp at all. Okay, so on this module, right here, we have the exact same component that is on the other one. These are completely the same. Same part number, everything. They're exactly the same. So there that is. Oh, there that is. There are 2 capacitors. You can't see it due to focus things. Oh, maybe you can. So the 2 capacitors which help it. It's the same case on the other board. There's also 2 capacitors on this one. You can see them right there and right there. But these are a bit bigger actually. A bit strange, but yeah, these are bigger. So back to the other one. So this one can charge it, just like the other one. But the difference to this is that when you want to charge it, you want to discharge it. And when you want to discharge, you want to make sure that the voltage of your battery cell never gets below whatever you want to set it. So it can be 3.2. In my case, that's where I like to keep it, because you can cycle a lot of times. But if people want to have a very high volume of energy, like a big amount of energy inside the battery, they can pull it all the way down to 2.5 and 2.5 volts. but it's quite aggressive, and the batteries don't really like being at 2.5 volts. So you want to discharge it, and the difference to this other one is that it has 2 more terminals, and the 2 other terminals on this one, they are the discharge terminals. So you connect your battery up, you can charge it via USB or the 2 5-volt ports, ground and 5 volts. So you can charge it here, and you connect your battery, and whenever you want to have a load on it, you want to discharge it, have something kind of power bank pulling out energy of a battery, you connect them to these 2 terminals. So these are battery, these are charging, and these are the discharge terminals. And the reason they are their own terminals is because when you discharge it, you need to be able to break the circuit. So some kind of transistor needs to be able to break the circuit to the battery when it gets to a too low voltage, because whenever there's a voltage on the battery, you can still pull out more energy. The battery will get destroyed, but you can always pull more energy out of it as long as there is a voltage across the 2 terminals. But by connecting the battery to the inner terminals and connecting the load or whatever you want to charge the USB to your phone or whatever, you connect to these 2, so they're not directly connected to the battery. They're connected to the battery through a transistor that can shut it off, break the circuit so the phone doesn't charge anymore and the battery doesn't get destroyed. So the other components that are on here are the transistors that can break the circuit. So right here we have the charging unit, and then we have this piece here, which is a transistor. A transistor is a electrically controlled switch. So it's like if you have a connector like this, yeah, you can how does this work? Here's one. So this is a normal switch. Yeah, can you see this? It has 2 terminals on it, and click it once, these are connected. Click it once again, and these are disconnected. Okay, so this is a mechanically operated tactile switch. But this inside of this unit, or this surface-mounted device, there is a switch which is electrically controlled, and it's called a transistor. So this one can break the circuit, just like this one can break a circuit. And this tiny module, which is or tiny component that is right next to it, is the voltmeter. So this device, or this surface-mounted device, measures the voltage across the battery, and whenever it gets too low, it tells this transistor to shut it off. So where the other one here can only charge the battery up to full capacity, this one can both charge it and discharge it. So whenever this is connected to your battery, you cannot overcharge your battery, and you cannot discharge this too low. It would shut off by itself. So this module can put energy into a battery safely and pull it out safely. It still burns off all the excess voltage, so the philosophy is still not quite good, because it's a lot of waste in this. When you charge with this, there's a lot of waste. So you can put energy into a battery and you can pull it out again. Okay, so what you need when you pull energy out of a battery, what you need is to match the voltage of your device. So your device, whatever it is, iPhone, whatever, a cell phone, USB is run at 5 volts. So the energy coming out of the battery is between 3.2 and 4.2, and you need to step it up. We talked a bit about steppers, so you need to step up the voltage to match whatever is on your device. So 4 volts come out, and you have to step it up to 5 volts through the coils, the techniques we spoke about last time. So you need one of these. These are 4 modules, still connected to the circuit board, but these can be broken off, so they are individual modules. So these modules do the fancy thing that they have 2 terminals. All this is switching components that step up the voltage, and they attach directly to the USB. So when you have your USB cable, here it is. You have your USB cable. It connects through this, yeah? Okay, so when you take this module, connect the battery to it, connect the discharge ports or terminals, connect those to these 2 terminals down here, and then you can plug in the device for charging your phone. So got a lot of cells, and you parallel combine them all, like so. Maybe I can peel this back, show it to you. So you can see this. These are all interconnected. These wires make sure that if something burns, this single wire will burn over at the middle and will not damage the other parts. But this is still quite a risky system. But yeah, all these are parallel connected. They're all connected to each other at this side, all connected to each other at the other side. And here at the top, you can see the 2 components I was talking about. This one makes sure that via this USB socket, I can charge the cell, the batteries, and these 2, they are connected by switch to so the main battery package is goes through a switch into this, because this takes a little bit of current always. When these components are connected to the battery, they take a tiny amount of electricity to just keep running. So I have like a disconnect, like a manual disconnect. But whenever this is turned on, this still manages the battery. So if the voltage of these batteries gets too low, it still cuts off. And this tiny component can cut off this entire pack. It's quite nice. It's due to the low voltage, because this is only like 3.5 volts. Oh, you can actually see that it is 3.89 volts is the voltage of this package. So the voltage, the battery gets in here, it goes to the stepper, and this right here is a USB to charge something else. So with only a battery, a raw battery, and with only a battery and those 2 modules, you can take and make a power system. So here it is. Take your USB cable, you turn it on, connect it, and you take some kind of device that can be charged, plug it in, and it charges. So with that tiny amount of knowledge and components, you can build a power bank. That was all for today. I will, next time, we will go a bit into depth about how to get electricity out of sockets like these. So it's a bit like stepping up the game, because whenever you're managing low voltage systems, things can go wrong, sparks can fly. It doesn't really matter, because it's like a low voltage system. But whenever you are messing around with higher voltages, it gets more dangerous, and it's connected to the grid, so the grid can always supply a lot of power. So it's a bit more risky maybe, but you have to be more careful. So I have gotten this component because I have a dream about making a big power bank that can be charged fast, and that can be charged from the mains directly from the socket in the wall. So I have ordered or gotten this from eBay. This is a quite big stepper. This one is like half a computer's power supply. So this is like the half capability of a computer power supply. So this is quite big, but it turns energy from the wall, It turns into 26 volts at 8 amps. 24 volts at 8 amps. And so I have like a huge supply of 24 volts when I click this into the wall. And whenever I have 26 volts, it is in the range of these. We have spoken a bit about these. And these can be managed at the current level. So my dream is to make a power bank that has this attached on top, and then a series of these, because you can attach like 8 of these to this one and still get the optimal amount of power out of it. And these should be charging my big cells. So because I want it to be a big battery with a large capacity, I cannot just stack all, because I want it to be quickly charged as well. So normally when you have like a big battery, you take them all and you juggle them up like this, put them like this, and you'll see this all over the place. And they are like stacked and taped together. And I've made packs like this. Actually, the one you saw the last time, this one is exactly that. This one is a big power bank, a stack of batteries, all parallel. So this is so these are all stacked together in like a big lump. And then we have these circuits. I will tell you about these later, but these are almost the same as the other components that we have seen. But these are all stacked together. So if you want to charge this fast, because this can be charged fast, but it gets hot. Whenever they charge them fast, they get hot. So in the middle of this, it will be very, very hot. So the bigger and bigger the cell gets, the more you have to manage the heat, because the heat has a very hard time dissipating through from the center to the surface of this battery, and there's this plastic encasing on it as well. So my dream is to make like a big battery with these cells, but instead of stacking them tightly, I wanna have them where there are like gaps in between them, so I can make it like huge, because they can dissipate the heat off them. And then I bought these tiny ventilator heating, what these called, fans. These are like small computer fans, and these should be mounted in some kind of position to blow outside air through these batteries, so that even if they got hot when I charge them fast with this, because I can manage the current with this one, so I can manage like put in, I don't know, 2 amps or something into these cells. So this one goes to the mains. This one charges like 2 or 3 of these, and I would have like a stack of these, and then some kind of fans that whenever it's charging, they're like sitting on the bottom or somewhere in close proximity and blowing air through it, and then covered it all in some kind of plexi system. I have plexiglass, something kind of structure, and I'd order some plastic sheets from eBay also. So that's my dream. So next time we're going to talk a bit about these big boys, and about how to pull energy out of the mains. So see you in the next one.